All right, today we're diving into one of Python's most powerful and, honestly, most essential tools, the dictionary. And trust me, it's way more than just a data structure. It's a completely different way of thinking about how you organize information in your code.
Just think about it for a second. In the real world, data is hardly ever a simple list, right? It's all connected. Your contacts list isn't just a bunch of names. It's names linked to phone numbers. A menu isn't just a list of food. It's the food linked to its price. So how in the world do we actually handle that in our code?
Well, that's exactly where Python's dictionary comes into play. It lets us build this web of interconnected data, which is precisely what you need for handling more complex real-world information.
Probably the best way to think about a dictionary is to picture a digital filing cabinet. Seriously. Instead of having a messy pile of data all over your desk, you get to organize everything into these perfectly labeled folders, and that means you can find exactly what you're looking for, instantly.
And this right here is the absolute core concept, the key-value pair. Every single piece of information, which we call a value, is tied to a unique label, which we call the key. The key is the label you slap on the folder, and the value is, well, whatever documents you stuff inside it.
And you know what? Getting started is super simple. You can just use curly braces with your key and values separated by a colon. Or you could use the dict constructor if you prefer. Honestly, both ways work great, and they both give you a brand new, ready-to-use dictionary.
Okay, but before we just start throwing data into the shiny new filing cabinet, we've got to go over a few ground rules. These rules are what make dictionaries so incredibly reliable and powerful.
So let's break these down. First, keys have to be unique. You just can't have two folders with the exact same label. If you try, the new one just overwrites the old one. Poof. Second, and this one is absolutely crucial, keys must be immutable. That means they can't be changed after they're created. They're like permanent labels. The values inside, though, they can be anything you want. Strings, numbers, lists, whatever. And a really cool feature in modern Python is that dictionaries actually remember the order in which you added things.
So what does that immutable rule actually look like? Well, this slide shows it perfectly. Things like strings, numbers, or tuples, they make great keys because they can't be changed. But something like a list? Nope, that won't work, because lists are mutable. You can change them. Python needs that key to be set in stone, so it always knows where to find your data.
Okay, rules are down. Now for the fun part. Let's actually put this dictionary to work and see what kind of things we can do with it.
So you need to grab something out of your dictionary? Easy. You just give Python the key, kind of like asking for a file by its name. The most common way is to use square brackets, but you can also use the .get method. The big difference? If you ask for a key that doesn't exist using square brackets, your program crashes. But .get is a little friendlier. It'll just give you none back, no drama.
And this is where it gets really elegant. Whether you're adding a brand new item or just updating one that's already there, the syntax is exactly the same. Python is smart. It checks if the key exists. If it does, it updates the value. If not, it just creates a whole new key-value pair for you. Simple. Of course, you're going to need to remove things too. You've got four main tools for the job. Del is your straightforward "get this thing out of here" command. Pop is a bit more clever. It removes the item, but it also hands you the value back, which is super useful sometimes. Pop item is great for when you just want to remove the last item you added. And clear? Well, clear just nukes everything and gives you an empty dictionary to start over. At some point, you're going to need to look at everything inside your dictionary. You've got options. You can loop directly over the dictionary itself to get just the keys. If you only care about the values, you can use the .values method. But the most powerful way, for sure, is using the .items method. That gives you both the key and the value together in every single step of the loop.
Okay, so we've seen what they are and how to use them, but what's the big deal? To really get why dictionaries are so amazing, we need to understand the why. What makes this data structure so special?
This is the dictionary's superpower. It's called constant time performance. And what that means, in simple terms, is that it takes the exact same amount of time to find an item whether your dictionary has 10 entries or 10 million. It just doesn't slow down. Think about that. It's like finding a specific book in a library just as fast whether the library has 10 books or 10 million. It's kind of mind-blowing.
So how is that even possible? The secret sauce is a process called hashing. See, when you give Python a key, it doesn't actually search through the dictionary one by one. Instead, it runs that key through a special function that instantly calculates the exact spot in memory where the value is stored. It's not a search, it's a direct calculation. And that right there is why keys have to be immutable. If the key could change, its calculated address would change, and the whole system would just fall apart. And the power just keeps going. Remember how we said a value can be any data type? Well, that includes another dictionary. This lets you build these incredibly complex, nested structures that can model really detailed, real-world stuff, like a user profile that contains a separate dictionary just for their address information. So there you have it, the Python dictionary. It's not just a box to store data. It's a powerful way to model the complex, connected world all around us. So the next time you sit down to code, ask yourself this: what real-world object could I model? What problem could I solve with this amazing tool?